all of these, they're differing symptoms, all with similar appearance, all from the same disease. Whirling disease affects juvenile fish, fingerlings, and fry, and causes skeletal deformation and neurological damage. Fish whirl forward in an awkward corkscrew-like pattern instead of swimming normally. They find feeding difficult and are more vulnerable to predation. The mortality rate is high for fingerlings. Up to 90% of infected populations will die. And those that do survive are deformed by the parasites residing in their cartilage, bone, and neurological tissue. They act as a reservoir for the parasite, which is released into the water following the fish's death. The parasite is not transmittable to humans that we know of at this time. When infected fish die, it restarts the cycle, and fry can then become infected. Fry and young fingerlings up to an age of 5 weeks, once infected, will develop the symptoms. There is no therapy or known cure. White spot disease. We see this disease a lot in aquariums as well. There's a lot of different reasons for it, but we want to deal with wild fish. So, white spot disease, or itch, pronounced ich, is highly contagious freshwater fish parasite. Ichthyophthirius multifilus, causing tiny white spots like salt grains on skin, gills, and fins, leading to flashing rubbing. In other words, they'll flip to their side, they'll rub against stuff, lethargy, and clamped fins. Symptoms: visible white spots like tiny salt or sugar grains on the body, fins, and gills. See here? Behavioral changes: flashing. You'll see them, they'll flip to their side and rub against the bottom, especially if it's gravel or something. You'll see them, they'll be continuously rubbing against trees or whatever, foliage and stuff in the water. But mainly it'll be a turn, and they call it a flash because when they turn and they like rub their side along the bottom, it causes a flashing on their sides that comes up, and can also be confused with them trying to nest or build nests, build holes for nest. They also will have excess slime production. Okay, rapid breathing, gathering in water at inlet or gathered at water inlets. They're trying to do whatever they can to get that parasite off of them. That's why we call it the itch, or ich, because it makes them itch. Causes and life cycle. The free swimming stage, the theront, infects the fish. It burrows under the skin as a trophont to feed, forming a white cyst. So what you're seeing is the symptoms of the parasite that is now under the fish's skin. For reproduction, it leaves the fish, insists on surfaces, and divides into hundreds of new parasites. These theronts are released to find new hosts, completing the cycle. So we know it gets onto the fish, it burrows into the skin. This creates the white patches and lesions. Then it will leave the fish, reproduce itself, and spread. Water temperature affects the speed at which this happens. Water temperature affects the speed at which this happens. Warmer waters speed up the cycle. So you will see this a lot in more tropical fish and so on, warm water fish, in aquariums as well. If the parasites do not find a new host within 72 hours, they will die. Also, when they're in this state, the only way that you can kill them with chemical treatments is when they are in this new developed state waiting to find a host. Diseases caused by crustaceans. Argillus or fish louse is caused by tiny flat disc-shaped crustaceans that parasitize freshwater fish, feeding on skin and mucus, leading to irritation, tissue damage, and potential secondary infections. Infestations spread naturally through the water, infected fish, or contaminated equipment, peaking in warm summer months when eggs laid on hard surfaces like plants and so on hatch. You will find some places in Europe, they will require, before you go fishing at a site, that you stop at what they call a dipping area, and you must sanitize all of your equipment. And that is because of this and certain other mussels that they're trying to keep from reinfecting the waters. If you are caught not sanitizing your equipment before and after use on the water, even if you never put that net in the water, you've still got to sanitize it again when you leave, because eggs and so on may have washed up onto the shore. High water could have deposited them. If you are caught not following the rules on this, there are severe consequences. Primary cause. The parasitic organisms, Argillus, and it goes into different ones, are the direct cause, acting as external parasites, ectoparasites, that attach to fish. That's what you see down here. Okay. Water and fish movement, infestation, how infestations start and spread. Water and fish movement, natural water flow, infected bait fish, or introducing new fish, especially ornamental ones like koi and goldfish, spreads the lice. If they have not been through a decontamination, say you stock your pond or whatever, and those stocked fish have not been properly went through a decontamination phase, they can bring it into the water. Also, contaminated items, rocks, plants where the eggs could be, or even transport water can carry eggs or juvenile parasites into new environments. Environmental factors. Warm water above 10 degrees Celsius in spring and summer triggers egg laying and hatching, leading to population blooms. They prefer eutrophic or nutrient-rich and still waters. How they cause harm. Feeding damage. Argillus uses hooks and spines on its mouth part, the stylet, to pierce the fish skin, causing inflammation, lesions, and hemorrhages. Like you see the red hemorrhages here on this gill plate. See them here? All that. Okay. Enzyme irritation. Digestive enzymes further irritate the tissue. So they will bite into it, exert an enzyme to break down the tissue or whatever to feed, and this causes further irritation. This can cause secondary infections. Open wounds from lice can become entry points for bacteria and other parasites, like Costia or Ich, leading to severe disease. Again, we see the flashing for signs of infestation. Fish flashing, rubbing against objects, or hanging out the surface. Increased mucus, rented lips, increased mucus, lethargy, erratic swimming, and poor body conditions. Visible, often greenish-brown disc-like parasites on the fish's skin or fins. Moving along. Disease caused by worms. Leeches are a type of segmented worm, and yes, they occasionally will parasitize fish. Many can obtain a length of 5 centimeters in length and can be easily seen macroscopically with normal eye vision on the skin, such as you see over here. All right. Many species will not only attach to the main body, but the fins as well. The bite of a leech can lead to inflamed bite wounds. Like Agulhas, it is suspected that they can transmit viruses and bacteria from one fish to another, as they are not permanently attached to any one fish, but may move from one fish to another irrelevant of the species. As you see from here, it says it will attach to the fin base, but we have found fish with leeches in the mouths, attached to the gills, okay? Wherever these little beggars can get without being eaten, then they can attach themselves. And since they move from one species to another, they can pick up a parasite, a virus, or whatever from one, and the theory is, or the hypothesis is, that they can then transmit that to a different fish of a different species, if that fish is susceptible to that particular pathogen that it's carrying. Tapeworms. These parasites or their larvae are usually located in the animal's intestine, liver, muscle tissue, or even the body cavity. The adult Ligula intestinalis tapeworm will infest the intestines of water birds. The worm's eggs are then returned to the water when the bird defecates. The eggs must then be eaten by certain copepod crustaceans, which is called the first intermediate host, where the eggs will hatch and develop into larvae. These crustaceans will then be eaten by the secondary intermediary host, or intermediate host. This may be a fish or other predator of the crustacean. If this predator is a fish species, the larva then will bore through the wall of the animal's digestive tract, where it continues to develop into an adult. The parasite is found in many fish species' body cavities, but are not harmful to humans and will usually not kill the infected fish, but can cause reduced growth rates and reduced immunity to other parasites and infections. Now, the parasite that is of concern for humans who may eat raw or uncooked fish is the broadfish tapeworm, Diphyllobothrium. Diphyllobothrium latum, and related to other whatever species. Consumption of inadequately prepared fish infected with this can lead to an intestinal infection in humans called diphliobothracis. Which can cause symptoms like abdominal discomfort and potentially vitamin B12 deficiency. Proper food safety measures such as thorough cooking or freezing kill fish parasites and prevent infection from any potential fish-borne parasites. I normally do, if I'm going to be eating fresh fish, it has to be well cooked. If I am storing fish, they must be kept in a freezer, and I give them 24 to 48 hours before even considering cooking them. The U.S. Food and Drug Administration, FDA, advises cooking fish to an internal temperature of at least 145 degrees Fahrenheit or 63 degrees Celsius for 4 minutes. Also, freezing fish at temperatures of -4 Fahrenheit and holding that temperature for several hours can kill the parasite. Even if you do the freezing, I would say cook it as well. Okay, the broadfish tapeworm is Autochthonus in Europe to Europe is Autochthonus to Europe and has an established ongoing foci in specific areas. In other words, it's established in Europe and it can be really found in some specific areas as well. Fennoscandia and the Baltic region, which includes Finland, Sweden, Poland, Estonia, Latvia, and Lithuania. Alpine lakes in Switzerland, France, and northern Italy. Lake Geneva, Neuchâtel, Belle, Como, Maggiore, and Izo, where a continuous cycle of the parasite in the natural environment and humans has been documented. So there's documented evidence saying that these things will infect you. The Danube River region has also reported the parasite, though cases have declined. That research material is, well, almost close to 10 years old, if not older. So that may have changed. Sporadic cases have been reported in other countries like Austria, Czech Republic, Belgium, the Netherlands, and Spain, some linked to the consumption of locally caught fish, suggesting potential new foci or new focal points or regions where they can be found. Related species are also present in European fish stocks. They're found in the Fennoscandia and Baltic region and can infect adronomous fish like salmonids. They're found all throughout different species in Europe. Regions such as we've covered, northern Italy has ongoing circulations. The Baltic region, Finland is a major focus, with cases also reported in Norway, Sweden, and Estonia. Now, as we're in Germany, this is important. The Danube River region, the parasite has been sporadically detected in countries bordering the Danube, such as Slovakia and Romania, although some recent studies on the Slovak part did not detect it. Other areas of sporadic occurrences have been Ireland and Poland. In 2024, a case was documented in the Czech Republic where someone caught it from eating fish, linked to a fish caught in the Lipno Reservoir. Other species have been reported in humans in Europe, but these cases are typically imported via the international fish trade rather than from Autochthonous EU stocks. In other words, Autochthonous means within the region or within the country. However, also people who are getting imported squid and so on and eating this sashimi style or raw have been catching different types as well. Now, this is an important part. Known affected fish types is commonly found in freshwater species including pike, perch, burbot, Arctic char, trout, and other salmonids. Okay. Now, fresh caught sea trout If the trout have been caught in the ocean before entering brine or fresh water, they typically will not have this tapeworm. It is only a freshwater parasite. And then down here we have the intermittent, secondary, and final host species cycles. So you'll want to at least know what we have. The first is the crustacean. It's always the copod crustacean. The second is they will get into the liver or muscle tissues and body cavity. And then the final, we find them in the fish, humans, cats, dogs, anything that would be eating those animals, wild caught or whatever, even in birds' digestive tract. Remember, they're the ones that start pooping it out to begin with. And that ends basic diseases.